Okay, everybody. Today we're going to be learning about exponents and radicals. Okay, exponents you may know, or well, we'll go into it, but it's something like this, and a radical is this. Okay, so we're going to go into radicals first. What is a radical? Well, as I said, looks a little bit like this. Okay, now we're going to deal specifically with square roots. Okay, square roots is when you don't have any extra numbers. It just looks like that. Okay. Okay. There you go. Okay. So what is the simplified form of the square root of 160? Now, when we talk about simplified form, I mean it's basically just that. It's as simple as it can get. Okay, and there are several ways to do that. Okay. The first is removing any perfect squares. So if you look at 160, okay, it is 16 times 10, right? Now, which one of these is a perfect square? 16. Okay, so there are, many perfect squares. You've got 4, 9, 16, 25, 25, 36, 49, 64, 81, 100, 121, etc., etc., etc. Okay, so removing the simplified form means that we're going to remove this 16. Okay, so what's the square root of 16? Well, the square root means, the square root of 16 is 4, right? Because 4 squared equals 16. Okay, so that means when we take out the square root of 16, we're going to put it outside the house. So you got two sections. You got inside the house, which is right here, and outside the house, which is over here. So we're going to take the square root of 16 out, the 4, and put it outside the house. Now what's left inside the house? Well, that 10. Okay. Now, are there any perfect squares in 10? No, there are not. So we're going to leave it inside the house. Okay. So our simplified form of the square root of 160 is 4 times the square root of 10. Okay, and that's as far as we can go. Okay. Here's another way to think about it. Let me erase all this. We're going to do, we've talked about, or you have talked about with other teachers, prime factorization. This means that you're going to break down a number, in this case 160, into the smallest bits it can get to. Okay, prime numbers. Okay, so we've got 2 times 2 times 2 times 2 times 2 times 5. Each of these are prime numbers. If you multiply all these together, you can take a calculator and do it now. You're going to get 160. Okay, we are going to look for pairs of numbers, or in the future, letters. Okay, so what's a pair of numbers? Here's one. Here's another one. Are there any more? No, 2 and 5 aren't a pair. So whenever we see a pair, we're going to take the number that it's a pair of. So in this case, this is a pair of 2s. This is a pair of 2s. So we're going to take a 2 out in front of the house, another 2 out in front of the house, and then what's ever left is going to stay inside the house. Okay. So what do we get? Well, 2 times 2 is 4. Hopefully you know that. And 2 times 5 is 10. 4 times the square root of 10. This is the simplified version. So there are two ways to do it. Okay. Let's move on. Oh. Now, here's one for you guys to try. Pause it and do it. Let me erase this. Hopefully you paused it. So let's do it. What is the simplified form of the square root of 72? Well, there are two different ways to do it. Let's do it the prime factorization way first, okay? So 72, we can break it down into 2 times 2 times 2 times 3 times 3. Okay? And there are many ways to do that, but basically break it down into factors and then break those factors down and so on and so on. Okay? I know that 72 is 8 times 9. 8 is 2 times 2 times 2. 9 is 3 times 3. So let's look for some pairs, okay? Well, we got a 2 and a 2 there and a 3 and a 3 here. Okay? Let's bring them out, okay? Outside the house. 2 times 3. What's left inside the house? Well, it's that 2. So what's 2 times 3? Hopefully you know that it's 6. So you get 6 times the square root of 2. Okay? And look at that. That's C. Now, the other way to do it, and I'm going to erase this, so if you need to pause it, pause it. The other way to do it is think of all the different factors of 72. Okay? You've got, as I said, 8 and 9. You've got 24 and 3, 36 and 2. Okay? 36, as we said over here, is a perfect square, the square of 6. So if we do 36 times 2 and we take this out and move the 6 over here because it's a square root of square of 6, well, then we get 6 square root of 2. Let's move on. Okay, so removing variable factors. Variables, of course, are letters. So we're going to remove letters. Okay, this is what I was talking about before. So we're going to break this down the same way using prime factorization. Okay, let's break it out. So what's 54? The prime factorization is 2 times 3 times 3 times 3. Okay, now hopefully you know that n to the 7th power is n times n times n times n times n times n times n. Okay, 7 n's, right? So we're going to write that. N times n times n times n times n times n times n. Okay, this is definitely the long way, as you can see. But let's look for some pairs, okay? 3 and 3, that's a pair. N and n, n and n, n and n. We got 3 pairs of n's. So we're going to bring each of those, the individual number outside, right? And we're left with these numbers inside, right? No. These numbers inside, the green numbers, okay? So let's bring out the pairs, okay? So we got a 3, right? We got an n, we got another n, and we got another n. What are we left with inside? Well, 2 and a 3, and an n. Okay? So 3 times n times n times n. We just talked about n to the 7th power being 7 n. So 3 n's is going to be 3 times n to the 3rd power. Okay? Now what's left inside the square root? 2 times 3 is 6, and then we've got a lone n. So the simplified form of square root of 54n to the 7th power is 3 times n cubed, or n to the 3rd power, times the square root of 6n. It's not extremely simple, but it is this most simplified form that 54 times n to the 7th power can take. Okay. Okay. Now, there is another way to do this. Okay. So first off, let's deal with the 54. Okay, we know it's 9 times 6. Hopefully you know that 54 is 9 times 6. If you ever want me to show you a trick to multiply things by 9, just ask me in class. 54 is 9 times 6. So what's 9? Well, it's the square root of 3. Hopefully you know that. So we're going to take out a 3. Okay, it's going to be outside the house. Now, when you have n to the 7th, okay, if you divide that 7 by 2, okay, you get 3 remainder 1. This is something that you learned a long time ago with remainders and stuff like that, okay? So you get 3 remainder 1, okay? That 3 is going to go over here, into the 3rd, outside the house. That remainder is going to be left inside the house all by its lonesome, okay? So it's left with that 6, right? And then we have an n, okay? A good way to think about it is this. If you have an odd number inside the square root, you're going to have 1 left over, okay? So if it was a 6, you'd move it out over here and you wouldn't have any n's left inside there. Fractions. I know everyone is scared of fractions, but I'm not because I'm a math teacher, okay? Simplifying fractions with radicals. Well, a neat thing is, if you were paying attention before, if you've got square root of 9 times 6 or 50, square root of 54 equals the square root of 9 times 6, right? Which equals the square root of 9 times the square root of 6. And that's why we take out the 9. The square root of 9 is 3, and then we're left with that, okay? So I just sort of skipped over that because it's not really necessary to know, but it helps when you're learning about fractions with radicals. Because if you've got square root of 64 over 49, now that is a messy fraction. I don't know what that would be, but it certainly wouldn't be something that I want to deal with, okay? But the square root of 64 over the 49 is equal to the square root of 64 over the square root of 49. Now, these are numbers we can deal with, okay? What's the square root of 64? Hopefully you know it's 8. What's the square root of 49? Again, hopefully you know it's 7, okay? 8 over 7 is the answer. So if you put this into your calculator, you would get 64 over 49, which, let me whip out my calculator here, is 64 divided by 49. Well, that's, of course, 1.306122449. Everyone knows that. But if you hit the square root button, you would get 1.142857143. Very helpful. However, that is 8/7. Okay. Hopefully you don't have that memorized. Make me look bad. Okay. Ooh. So now we've got some letters involved. Okay, but that's okay. That's okay. 8x cubed over 50x, because we could solve it like we did before. 8x cubed over 50x. Oh, I'm sorry. The square root of 8x cubed over the square root of 50x. So the first thing we're going to do is we're going to solve it like we normally would. Square root of 8, well, that's going to be 2 on the outside and 2 on the inside. Okay? Because it's 4 times 8, right? The square root of x3, well, if we do it the short way, we divide this by 2, we get 1 on the outside, and we're a remainder of 1 on the inside, okay? If you want to do it the long way, 2 times 2 times 2 times x times x times x. Here's a pair, here's a pair. So we get 2x on the outside and 2x on the inside. Okay? So 2x and the square root of 2x. Now let's, on the bottom here, square root of 50x. Well, 50 is 2 times 25, right? So what's the square root of 25? You should be yelling these out, freaking out your parents because you're yelling out 5 in the middle of the night. Okay? 5. So we're going to take out a 5. What's left inside? Well, let's do the long way here. 2 times 25. Nope. I hate this thing. It does not have an eraser. 2 times 5 times 5 times x. So we have that pair of 5, so we're going to bring that out. What's left inside? Oh, that's okay. 2, the square root of 2x. Now, what's interesting about this? Well, if you've noticed that we've got the square root of 2x on the top and the bottom, then you know that they cancel each other out. So what's our answer? What's the simplified form? Well, it's 2x over 5. If you saw this, you would be crazy if you knew that this was 2x over 5, okay? I certainly didn't know that. But you do the math, you realize that the square root of 2x cancels out, and you're left with your answer. Now, here's one, and I'm going to erase it for you. Here's one for you guys to try. Again, pause it. I'm going to take a swig of water. By the way, I'm doing this with my new Britney Spears microphone. If you would, tell me how it sounds. Hopefully it doesn't sound too horrible. Delicious water. Oh. Okay, so we're going to break this in half, right? If you know what 144 ninths are, you are a math genius, right? But let's write out this way, 144 over 9 is equal to the square root of 144 over the square root of 9. That's interesting what I just did there. Square root of 9. Okay, what's the square root of 144? It is 12, and the square root of 9 is 3. What's 12 over 3? It is 4, which is B. Okay, you should be fairly comfortable with the square roots of, I'd say, at least 1 to 15. Okay, technically 1 squared is 1, so you don't really have to worry about that. But you got 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. I always forget 14. I think it's 180, 196, and then 225. Okay, this is 15. It makes it easier in the long run. But again, if you just broke these two down to the prime factorization, you would get 2 times 2 times 2 times 2 times 3 times 3, and you could take out pairs till you got 12. Okay. Next. Rationalizing denominators. Rationalizing. There is a rule in algebra that your answer, whatever it is, cannot have a square root on the bottom. Okay, it's just a rule in math. The math has got a lot of rules. This is one of them. Okay, so how do we get rid of it? Okay, let's take 3/7. Okay, 3 or the square root of 3 over the square root of 7. Okay, we need to get rid of that square root of 7. We don't like it down there. Okay, now what we're going to do is we're going to multiply this by 1. Okay, as you know, anything you multiply by 1 is itself, right? 16 times 1 is 16. The square root of 3 over the square root of 7 times 1 is the square root of 3 over the square root of 7. Now, we can write 1 however we want to, okay? In this case, we want to write it the square root of 7 over the square root of 7. That's 1, right? Any number over itself, 5 over 5 is 1, 7 over 7 is 1. The square root of 7 over the square root of 7 is 1, okay? Now, we talked about this slightly, but if you have the square root of 3 times the square root of 7, it equals the square root of 3 times 7. Okay? If you have the square root of 7 times the square root of 7, it equals the square root of 7 times 7. Now you might want to see why this is called. Now you might see why this is called rationalizing. Okay? Because what's the square root of 7 times 7? That's a pair, right? So we're just going to take out of the box. If there's nothing left inside the house, then we just get rid of it. Okay? So 7 times 7 is 49. The square root of 49 is 7. Now what's on top? The square root of 3 times 7, which is 21. Now can't do anything with that, but this is a rational fraction because you don't have a square root on the bottom. Okay? It's still going to be a messy number if you try to put it into a calculator, but we don't care. All we care is that you don't have one of these. Okay? A square root on the bottom. Okay? So again, when you are rationalizing a denominator, you're going to multiply it by the denominator, which in this case is the square root of 7, over itself. Okay? That's going to rationalize it. Now, here's the same exact thing. Okay? Except now we've got letters. The thing that makes it harder, but it really doesn't, because it's the same process. Okay? Square root of 7 or the square root of 8 over n. So what are we going to multiply it by? If you screamed out the square root of 8 over n, the square root of 8n over the square root of 8n, you are right. Square root of 8n over the square root of 8n. Which is technically 1, right? So the square root of 8n times the square root of 8n, we should know is just going to be 8n. Okay? The square root of anything times the square root of anything is going to equal anything. That's just a rule in math. Now, 7 times 8n is, again, 56, and the n just stays the same. Okay? Now, let's look at this 56, okay? This 56 just happens to be 4 times what? 14, right? So 4 is a square root, so we can take out the 2. So let's do it the long way. 56 is 2 times 2 times 2 times 7. We have that n in there, right? So we're going to take out this pair. And then this 2 times 7 times n is going to stay inside. We've been doing that in green, haven't we? Okay. There you go. Okay. So this equals, 2 times the square root of 14n over 8n. Now it's still not simplified. Okay, this is just fraction stuff. 2 over 8 is what? 1 over 4. So that means that we get 1 times the square root of 14 n over 4n. Now, if you have something times 1, well, you don't have to really put that 1, do you? So, our final answer, after all of that math, is the square root of 14n over 4n. That is our answer. Let's make this a little bit more clear that this is underneath that. That is called rationalizing the denominator. What is an exponent? This is the next section, by the way. An exponent you should know. Okay, you've been dealing with exponents. Maybe it's only been x squared or something like that, but an exponent is the little number. Let's look at. I've got a little, or in fact, a big x to the power of 3. Now let's talk about how I said it. Okay, just so you don't sound like a dope when you're talking about math. How do you say this? X squared. We know that one. If it's got a 2, if it's got a 3, you can do x to the power of 3 or x cubed. Anything else is going to be x to the power of whatever. X to the power of 7, x to the power of y. It could be that x to the power of 15. Anything, but you're going to do x to the power of blank. Okay, whatever this number is. Okay? Now there are some rules of exponents. And they're not just rules, they're laws, I think. Okay. Oh, no, they are rules. They're not laws. The 5 rules of exponents, okay? So there are 5 rules. The first rule is the zero exponent rule. And it's really simple. Anything raised to the power of 0 or raised to the 0 power is 1, okay? Here's an example. Negative 3.6 to the power of 0. What is it? 1. Here's some more examples. Let's erase. Xy cubed all to the power of 0. Well, that equals 1. Pi to the power of 0 equals 1. Anything to the power of 0 is 1. That's all you need to know. Anything to the power of 0 is 1. If you want to know why, I can tell you why, but just take my word for it. Anything to the power of 0 is 1. Rule number 2, the negative exponent rule. I'll read it out loud. Negative exponents in the numerator get moved to the denominator and become positive exponents, and vice versa. I know that's a mouthful, but look at the example I have for you here in baby blue. Okay, a to the power of negative n is equal to 1 over a to the power of positive n. Okay, that's a negative exponent rule. Okay, and if you had 1 over, that's ridiculous. 1 over a to the power of negative n. Well, you move that to the top, a to the power of n. Okay? Let's do some examples. Okay. What is the simplified form of each expression? Well, 9 to the power of negative 2. Well, okay, I don't even know how to do this, show you the way. We move this 2, we make it positive, and move it to the denominator. There you go. 1 over 9 squared. Okay? Now, you need to go a little bit further because 9 squared is 81. So the answer is 1 over 81. Or 1/81, which is a mouthful. But that's basically it. You move it to the bottom, or sometimes you move it if it's on the bottom already. You're going to move it. Rule number 3, the product rule. Let's read it. If you multiply two exponents with the same base, you keep the base and add the powers. A to the power of m times a to the power of n equals a to the power of m plus n. As you notice, they both have the same base of a, right? Let's see an example. That's the best way to get into this. What is each expression written using each base only once? Okay, so 12 to the power of 4 times 12 to the power of 3. Okay, they have the same base. What is it? That's right. It is 12 is the base. So what are two exponents, 4 and 3? Because they're multiplied, we're going to add them. Now, hopefully you know, and you don't need to use a calculator, 4 plus 3 is 7. So our answer is 12 to the power of 7. And that's it. That is it. Technically, if it was smaller, if it was like 2 to the power of 5, maybe I'd ask you to go and actually give me the number. But do I really care that 12 to the power of 7 is 35,831,808? No. I only care that 12 to the power of 7. That's the answer I'm looking for. Okay, you don't need to go any further. Now, we talked about this. -2, we have a negative now, but don't worry, don't fret, because it's the same principle. First of all, what's the base? -5. So we're going to leave that there. And then what are our two exponents? -2 and 7. So we can do -2 plus 7. What is -2 plus 7? Well, it's 5, right? So you get -5 equals -5 to the power of 5. And you can leave it at that. I don't need you to go any further and tell me like, oh, well, as you all know, -5 to the power of 5 is -301.25. Okay? It's how each expression is written using the base only once. So you want to leave it as this. And that is your answer. Okay? Now, here's one for you to do. Pause. Did you pause? Did you pause? Did you pause? So, how'd you do it? Well, what's the base? It's 8, right? And then we do 3 plus 6, which is 9. So 8 to the power of 9, which is, now, they try to trick you. Okay? And if you see this in a if you see this in a thing, they have a number here, don't automatically think it's the number, because it's definitely not the number. Okay? If anything, it's not the number. I mean, that's nothing right there. Okay? So, there we go. That's it. Next. Rule number 4, the quotient rule. Now, quotient is not something that we use a lot in math, but it basically means the answer after you divide. Okay? No, yes. So if you divide two exponents with the same base, you keep the base and subtract the powers. Basically, it's the opposite of the product rule. So a to the power of m over a to the power of n equals a to the power of m minus n. Pretty simple. Let's see it in action. Simplify the expression 5 to the power of 7 over 5 to the power of 3. Well, first of all, we know we got the same base, right? So what's the quotient rule? We subtract. So it's 5 to the power of 7 minus 3. Okay. What's 5 to the power? What's 7 minus 3? Well, it's 4. 5 to the power of 4. Again, you could give that answer. If you gave, this is a kind of a smaller one, so if you put 625, that I'd be okay with that. Okay? But what I'm really looking for is this, that you understand that when you have a fraction, it's 7 minus 3. Rule number 5, the power to power rule. Power to power. The power to power rule is a to the power of m. Let me read it. If you raise a power to a power, you multiply the exponent. So a to the power of m to the power of n is a to the power of m times n. Okay? Pretty simple stuff. Let's see it in action here. What is the simplified form of 2 to the power of 3? All of that to the power of 4. Well, we know that we're going to multiply these. So it's 2 to the power of 3 times 4. What's 3 times 4? 12. So our answer is 2 to the power of 12. And that's it. That is it. If you take a power of a power, you multiply the exponents. That is simple. Oh, okay. This is sort of a cheat sheet, if you will. I don't know if there's a way to print out this particular thing, but I also have something up there for you to use. Okay, so if you need to look this over, you can. But let's go ahead and move on. Okay, so we've talked about the 5 rules of exponents, but we've been dealing mostly with numbers. Okay, we haven't dealt at all with algebraic expressions, which, if you see in this case, has to do with letters. Okay, but the rules are exactly the same. So multiplying powers. What was the rule here? Hopefully you just watched this so you remember that it is you add the exponents. Okay, so z 4 times z to the power of 5 times 9 times z to the power of negative 12. Okay, so the first thing I want to mention is if you've got these coefficients 4 and 9, first thing you're going to do is multiply them. So 4 times 9 is 36. Okay, so then we're going to do the z. So z to the power of 5 plus negative 12 or minus 12. Okay, so 36z to the power of negative 7. That's a little bit off. Even further, let's move over here. Even further, you can do 36 over z to the power of 7, right? Because that negative exponent, we're going to flip it to the denominator. This is the proper way, okay? You really don't want to have any negative exponents in your answers, okay? So this is the way you're going to answer it. 36 over z to the power of 7. Okay, so we have another one. First thing we're going to do, take these coefficients, 2, 9, and 3, and multiply them by each other, okay? 54. That's it, okay? So if you see, now we've got A and B. Okay, we've got 2 different things, but don't worry about that. First thing we do is we're going to do the A's, okay? So we've got A to the power of 1, because if it's just by itself, it's A to the power of 1. And A to the power of 2. So what's 1 plus 2? Well, hopefully you know that it's A to the power of 3. Now B, we're not multiplying anything, so it's going to stay the same. So that's it. We multiply the coefficient, 2 times 9 times 3. We multiply the A's, A to the power of 1, times A to the power of 2 to get A to the power of 3. And then the B to the power of 4 just sort of stay the same. Okay? Next. Okay, so same thing. Dividing exponents and algebraic expressions. We're going to deal with letters here, okay? So if you see, we've got m's on the top and the bottom, and n's on the top and the bottom, okay? So let's rewrite it. M power of 2 times n to the power of 4 over m to the power of 5 times n to the power of 3. So let's just pay attention to the m's right now, okay? M to the power of 2 over m to the power of 5. So what would that be? M to the power of 2 minus 5, right? The same rule. This is the quotient rule, okay? So m to the power of 2 minus 5. What's m to the power of 2 minus 5? Well, m to the power of negative 3, okay? N to the power of 4 minus 3, right? Quotient rule. 4 minus 3 is 1, so you're just left with n to the power of 1, okay? Now, as I mentioned before, we don't want to have any negative exponents. So we're going to move this m to the negative 3 to the bottom of a fraction. The n stays on the top. Let's get n over m cubed, or m to the power of 3. And that is our answer. Fairly simple stuff. It's the same exact principles, except now we're done with letters. Shouldn't be scared of that. Okay, Power of powers. Again, same exact thing, except now we've got letters. So what's the rule for power of powers? Hopefully you said, oh, you multiply the exponents. The same thing here. A to the power of 4 times 7. What's 4 times 7? 28. So the answer is a to the power of 28. That took, what, like 15 seconds to solve? I mean, it's pretty straightforward. Once you know the five rules, you shouldn't have too much trouble with exponents. So we've talked about radicals. We've talked about exponents, but there's a sort of a third mid category called rational exponents, okay? So in rational exponents, you're going to have your x, but it's going to be the power of a fraction, okay? X to the power of 1/2. Now what this means is 1/2 in particular means the square root of, okay? So and we're not really going to go too far into it, but you can also have, this is a square root. You can also have cube roots. It's going to have a little 3 there. Or, oh, this is the 4th root of x, okay? So this number there and here is going to be your denominator always, okay? So typically when we do a square, the denominator would be 1, so you don't have to worry about this, okay? The top number is going to be the power of this letter, okay? So for example, if you had x to the power of 2/3, the numerator, I'll do that in red, is going to be your exponent, say 2. Your denominator in blue is going to be your root. So you've got this cube root of x squared, or x to the power of 2/3. Now you don't really need to know how to figure this out. However, you're going to have to know how to add them, but the same rules apply. You're just dealing with fractions, okay? So you're going to add 2 fractions, or you're going to multiply 2 fractions, or you're going to multiply a fraction times a whole number, okay? You don't really need to know this kind of thing yet, but you should know that x to the power of 1/2 is square root of x. Okay, so we're going to jump right into it. Look at this. This is a whole messy mess, okay? But break it down, okay? The first thing you want to do is deal with your exponents, okay? So we've got 5, 3, and 2. I mean, not exponents, the coefficients, okay? So 2 times 3 times, these are all multiplied by each other. So 2 times 3 times 5 is 30. So we're going to, whatever we want to have, it's going to have 30 in front of it, right? Now, let's deal with just the a's, okay? So a to the power of 2/3 times a to the power of 1/3. So what do we talk about? Okay, we add them together, right? So a to the power of 2/3 plus 1/3, which should be pretty obvious to you, but let's keep going. Okay. Now we've got b to the power of 1/4. B to the power of 1/4. B to the power of 1/2. So we go b 1/4 plus 1/2. Okay, so this is actually a little bit more advanced than kind of a problem you would see, but let's keep going. Okay, so let's bring down that 30. That's not going to change. Now a 2/3 plus 1/3, hopefully you know, is 1. So whatever we're going to have, it's just going to be an a. Okay, because a to the power of 1 is a. Now b 1/4 plus 1/2 is 3/4, so you're going to have b to the power of 3/4. Okay, and really you could stop there. Okay, or you can make it a little bit more complicated and have 30a times the 4th root of b cubed. This is your super final answer. But the point is that even though this is dealing with fractions, you don't need to know this part. You know that when you have b to the 1/2 times b to the 1/4, you're going to add those those fractions, those powers, to get your final fraction, okay? So this, again, it's kind of a mess, and this is advanced stuff here, but if you can do this, you can do the problems they're going to throw at you, okay? So let's do it part by part. First, let's do this part right here. N to the 1/2 to the power of 10, okay? So what's the rule? Multiply the powers, right? So 1/2 times 10. What's 1/2 times 10? That's 5. So you're going to have n to the power of 5 right off the bat. We've gotten rid of one fraction, okay? Let's do here. 4 times mn to the power of negative 2/3 to the power of 3, all to the power of 3. Now, this is going to be sort of a reverse distribution, okay? We're going to take that 3, we got to apply it to everything in there. So 3 has 4 cubed, 4 times 4 times 4 is going to be 64. Now, we're going to end up putting that in the front, but don't worry about that yet. Okay? M to the power of 3 is just m third, m cubed. Now, here's the interesting one. N to the power of negative 2/3 times 3. So we've got n to the power of negative 2/3 to the power of 3. And we're going to, of course, multiply them. So what's negative 2/3 times 3? N to the power of negative 2. So we've got n to the power of 5 times 64 times m to the power of 3 times n to the power of negative 2. Now we're not done yet, because what can we combine? These guys right here. Okay? So let's rewrite the equation. The coefficient's always going to come first, okay? So we got 64. M cubed, we're going to leave it right there. M cubed, okay? But now we've got n. Let's go here. N to the power of 5 minus 2, which, if you're advanced math, you know is n to the power of 3. Okay? That is a simplified form. Although, don't say I said anything. But, and again, this is as far as you need to go. However, interesting tidbit, that also equals, 4mn cubed. Because 4 cubed is 64, then you've got m cubed and n cubed. But this would get you an A right there. This is advanced stuff, guys. I promise you. Okay. We've got y cubed. Y cubed times y to the 5/2 to the power of negative 2. This is hard to say. Okay, this is why this stuff is on paper, because it's difficult to even say. Okay, so but it only has one different thing. So let's just do it in parts. Okay, y to the power of 5/2 to the power of negative 2. Well, we multiply those, right? 5/2 times negative 2. Now you can do your math. That's y to the power of negative 5. Okay, so now we've got y to the power of 3, right? This guy right here, times y to the power of negative 5. And what's the rule with multiplication? Y to the power of 3 minus 5. Or y to the power of negative 2. Is this the right answer? No. Why is it the right answer? Well, we never want to leave it with a negative exponent. So what's the negative rule? We're going to put that on the denominator. So our final answer is going to be 1. Because if there's nothing on the top, it's going to be 1. 1 over to the power of y squared. Now, let me erase this. There's a problem on the problem. Problem on the problem. Problem on the bottom. And I want you to do it. Now, this is an, give you a second to do this. I'll drink a sip of water. Okay, so the first thing you're always going to do is deal with this guy right here. So you have x to the power of 6 times negative 4. That's not too difficult, right? Okay, 6 to the power of negative x plus 4. Now, what's that? Well, it's x to the power of negative 24. And then you've got times x squared. Now, here's where they're trying to trick you. See this right here? You got that 48. because 2 times 24 is 48. But no, we're done with the multiplication with the power of the power. Now we're going to do the adding of the exponent. So what's 2 plus negative 24? X to the power of negative 22. And going further, we're going to put that over x over to make sure we don't have any negative exponents. We're going to flip that to get 1 over x to the power of 22, which is b. B.